All right, 3.1, exponential and logistic functions.
Nice. Thanks.
All right, so you should have the notes done for that.
I need to buy a new notebook. Mine is like completely filled up.
Well, at least you'll be able to start a new one like for the new semester, probably.
Yeah.
All right. Start with number 2. So it says, which of the following are exponential functions? For those that are exponential functions, state the initial value and the base. For those that are not, explain why not. So we have y equals 3 to the x. So would this be exponential?
Yes.
Okay, why?
Because
Like what looking at it tells you that it's exponential?
X is
It's the fact that x is in the exponent, but yes.
Wow.
Technically, we don't know that x is positive. That value for x could be,
X could be anything.
yeah.
Okay.
X could be anything.
Gotcha.
So yes, it is exponential. So the initial value is what happens when we put in 0 for the exponent. So if we put in 0 for x, what do we get? What'd you say? 3 raised to the 0 is what? 1. Anything raised to the 0 power is 1.
No, I knew that.
And what's the base?
3.
Yes.
Okay.
All right, for y equals 4 squared. Is this exponential?
No.
No. It's not exponential. It's actually a constant function.
Because it always equals the same.
Yep. 6. Y equals x to the 1.3. Is this exponential?
Yes.
Why?
Is that 1.3?
Because
What makes an exponential function, Josh? It's not exponential. Because the x has to be in the exponent for it to be
Oh.
exponential.
is that the only way?
Yes.
No. Okay.
This one is a power function. Because it's a variable raised to a power.
I took a 50-50 shot.
All right. Compute the exact value of the function for the given x value without using a calculator. They're not hard, I promise.
I just
8. F of x equals 6 times 3 to the x. And we want it when x is equal to -2. So we're literally just plugging it in.
Oh.
So 6 times 3 raised to the -2. 3 raised to the -2 is what? What do negative exponents do?
make it
Put it where it ain't, make it positive. Remember Mr. Cassism? Put it where it ain't,
Oh,
make it
yeah.
positive. So we would move it to the bottom. So this is 6 times 1 over 3 squared. And you don't have to write out all these steps if you don't need to. Like, I'm just doing it so that you have it to look back at.
Yeah.
But that would be 6 over 9, which reduces to 2/3.
Better to have all the steps out. Just
It's always better to have them to look back on, and then when you do your homework, if you're like, no, I don't need it, then you don't have to worry about it. But
yeah.
I go back sometimes and look at, like, when I had Mr. Cass, he didn't do any notes. There were no notes.
What did you do?
It's only examples. He would open the textbook and just start working problems.
Oh.
That was it. So, like, how y'all watch the notes video at home, like, there would have been none of that. Like, you wouldn't have got it in class, you wouldn't have got it at home, you would have we'd come in and we'd just do examples.
Oh, okay.
So I look back at my notebook sometimes to look and see, like, how he taught something or what it was, and I'm like, I have no idea.
Or like why it was that.
Because he didn't always write these steps, and sometimes he may have, and I just didn't write them because I was like, no, I got it. But then it's like going back and trying to look at something, I was like, I have no idea.
Oh my gosh.
I'm like,
At least
yeah.
he did table surf a lot.
He did table surf a few times for us. He also chest bumped some students one time. It was pretty funny. And one of them, they went to do it, and he fell over. I was like, oh, he was laughing too, but
Okay.
it was just so funny. I was like, ah,
That is funny.
oh my goodness.
That is actually.
It was a fun group of students. All right, f of x equals 8 times 4 to the x for x equal to negative 3 halves. So I think we may need to review what happens when we have a fraction in the exponent.
It's negative.
So 8 times 4 raised to the negative 3 halves. So if you have a fraction, okay, the numerator of the fraction is the power that it's being raised to. The denominator is like taking the root of it. I would recommend, if possible, that you always take the root first because it'll make your life a lot easier. Because having to cube 4 and then take the square root of it, now in this particular case it wouldn't be that bad, but it's a lot easier to take the square root and then cube that number, typically. Now it is negative, so I'm going to go ahead and move it to the bottom first. So that's 8 times 1 over 4 to the 3 halves. So then we would take the square root of 4, and I'm going to do this in 2 steps again so you can see it looking back. But you could do it all in 1 step if you were going to actually do it. So this is going to be 8 times. Taking the square root of 4 first is going to be 2, so 1 over 2 cubed, which is then 8 times 1 over 8, or just 1. So really these 2 steps here you could completely skip, and I mean, I would probably write this step at least so that you see it with a negative exponent, but you have to at least show where you plugged it in, and then if whatever happens and you get to 1, as long as you have the right final answer, that's fine. But obviously the more work you show, the more partial credit you'll get if something's wrong. All right, these ones say to determine a formula for the exponential function whose values are given in the table. So the table, I'm only going to write the part that we need for this problem. The other part you need for the problem you'll have in the homework. So 12 is asking us for g of x. So from the table that's given, gives you x values and g of x values. So when x is negative 2, g of x is 108. When x is negative 1, g of x is 36. When x is 0, g of x is 12. When x is 1, g of x is 4. And when x is 2, g of x is 4 over 3.
They give you that?
Yes, that's all given to you. I don't know why this thing is like not clear. All right, so then to do this, we find the formula for a times b to the x. Okay, so we have to figure out what's getting plugged in there. So a is going to be what happens when x is 0, basically, because this whole thing would just become 1. So a is going to be when x is 0. So when x is 0, a would be 12. So 12 times so then we have to figure out what's going for B. Any ideas? 3. Why 3?
I don't know. Just look up the pattern.
Okay.
It did.
So plug in a number. So if you put 3 here, let's just say you're trying. So you put 3 there. So 3 raised to, let's do the 1. That's 3 times 12 is 36. Well, it's supposed to equal 4, so that's not right. But possibly try 1/3 instead. So if I plug in 1 now, 12 times 1/3, 12 over 3 would be 4. So there's my answer.
Oh, it's close.
So notice, as x values get bigger, g of x values get smaller. So this is a decay problem, meaning this is going to be a fraction. I think for the one that you, well, maybe not. Never mind. Scratch that. I was going to say I think the one that you have in your, that you'll have to do for homework is the opposite, but it's not. If it was getting bigger, if g of x was getting bigger as x got bigger, it would be a growth function, meaning this would have been positive, or not positive. It would have been a whole number. All right. State whether the function is an exponential growth function or exponential decay function and describe its end behavior. So that's using limits. So 32 f of x equals 1 over e raised to the x. So would this be growth or decay?
That is
Okay.
such a good question. Let me just refresh.
So remember, e is a number.
Wouldn't it be decay?
It's decay.
Because it's a fraction.
Okay, because it's a fraction. It's a fraction with a positive exponent. So we care about what happens as x goes to negative infinity and as x goes to infinity. So the limit as x goes to negative infinity. So basically as x gets really, really small, so say negative 500, okay, what happens to this?
You said as x gets really, really small?
Yeah, so like negative 500.
Like that is the exponent.
It's negative.
Yeah. No, so it's still going to be positive, but you have a negative exponent, so what's happening? What does a negative exponent do?
You did,
Flips.
It's going to flip it, so you would end up with e to the x,
right.
basically, what you're going to end up with.
But it would still be positive.
So, yeah, so basically what you're dealing with in this situation, just for, I'm going to do it in a different color. So you're looking at 1 over e to the minus x, basically, is what's happening for a negative, really big number.
Why do I keep doing
This is the same as e to the positive x. Okay, so e is something about 2. So 2 raised to the 500 is what? Not actually, but
that? Oh.
Big.
really big. So this is going to infinity. And then my limit as x approaches infinity, so as x gets really, really big, like 500, I have 1 over e to the 500.
It's still positive.
It's still positive. But 1 over,
So it's small. It's small though.
it's really, really small. So 1 over a million is close to what?
Close.
Infinity. Negative.
What's a fraction that's like 1 over 200? What decimal would that be? Point
Point
000 something, which means it's close to
0.
0.
Oh.
Yep. We knew that, guys.
So with exponentials, one should either be, well, basically one should always be at infinity and one's going to be 0.
Oh.
So a decay function
So it's what?
looks like this. Starts big, gets small. Okay, so this is at negative infinity over here. This is at infinity over here. So it would be graphed like, well, it would be graphed something like that. So this is getting really, really close to 0, but it's never actually going to touch 0. Okay, this is, well, this is really going to keep, this is not a great graph, but don't mind the graph itself. It would keep going like that, basically. So it's going to go really, really high up to infinity for a decay function. For a growth function, it's just flipped. It's going the other direction. So 34, f of x equals 0.75 raised to the negative x. So what would this be?
Growth.
Why?
Because it's a. Oh wait, no, it's not.
It's decay.
because it's not a whole number.
But what's that exponent?
It's negative, so it'll be a fraction.
Well, so let's look at it this way.
It is, so it's
So
Isn't it?
you were right initially, Peyton.
oh,
So 0.75
I didn't mean to.
is, what is a fraction?
It's 3/4.
Okay, so this is 3 over 4 raised to the negative x. What does a negative exponent do? Because we've got, for it to be exponential, it's got to be a positive exponent.
It goes on the flip. It flips things.
Okay, so it's going to flip it. So f of x equals 4 over 3 raised to the x. It's a fraction, but it's what kind of a fraction?
Positive.
Improper.
It's improper, meaning it's
Oh.
bigger than,
Oh, it's bigger than 1.
it's bigger than 1. So this is a growth function.
Oh. Oh, so I didn't think it was
Like,
I don't mind it once I.
So you've got to get it to have a positive exponent first.
Gotcha.
So then looking at our limits, the limit as x goes to negative infinity, so a growth function
I got this.
looks like this. So at infinity, at negative infinity, so at negative infinity, what's happening? It's getting close to 0. At infinity, it's doing what?
Going to infinity
It's going to infinity.
It's going.
and beyond.
Yeah.
Questions, comments, concerns?
Impressive.
1, 3, 7, 9, 11, 31, and 33. This is not, there's not that much time left. This is not going to be due tomorrow. Obviously it's Wednesday, but it's due Friday. Tomorrow we will do 3.2 though, but I think there should be plenty of time tomorrow that you should be able to finish both sections in class.
Is there not a video for 3.2?
If there's not one posted, then there's not one. So it's possible that there's not.